Hello guys, my name is Brian Barbosa. I'm a computer science student at the Federal University of Juiz de Fora in Brazil, and also I am a research assistant for the Center for Research and Education on Aging, the CREA, from the University of California in Berkeley. And today I'm going to show you a library that we created on CREA for controlling stepper motors with the Vocore 2. The Vocore is an open hardware single board computer, and it's not very famous, but we are trying to make it famous to posting everything we create with the Vocore on the internet and recording these tutorials that you're watching right now. So anyway, I'm going to show you the library, and I'm not going to give you today a full review of the library because it's not a small code as the other ones that you maybe saw in other videos of this channel, and can make the video a little boring to explain every single line of this. So everything I'm going to say to you is that is a library for controlling stepper motors in legacy mode using a driver. On the beginning for this library there are three available models of drivers for using, and you can expand that. You can do your own implementation since the repository of the library is available on the description of this video. And if you create another implementation for another driver, you can send us a pull request for increasing this repository and making it better for everyone on the community of the Vocore. Okay, so the three models of stepper motor driver are the DRV 8825. There is to the A4988 and the TMC 2208. If you're using any of these three models of stepper motor driver on your project, you can easily use this library to control this driver, and through this driver control a stepper motor. Okay, if you want to use micro stepping of the legacy mode, of course, you can use it too. It works, and the instructions are on the repository on GitHub. It's not as good as the micro stepping of the ward mode of any other mode that these crazy drives that we have to these days have, but it's good enough, I think. And now I'm going to show you the code for testing it that we are going to run. And it's very simple. It's a very simple code, as you can see here. I'm importing everything from the library that I just showed you. And on the other lines, I'm defining the direction pin, the pin that sets the direction that the axis of the motor is going to turn, and that's going to be the pin 40, and a step pin that sends pulses to the driver to control the motor for given steps. Here I'm defining the initial direction. The direction is defined with the logical level of the pins. If it's high, it's to one side, and if it's low, it's to another side. Okay, another thing we have to configure is the number of steps per revolution. That's the full configuration of the stepper motor. The stepper motor that I'm using here has 200 steps per revolution. And now on the next line, I'm creating an object. The object is created by passing the minimum parameters that I pass for the object for creating the object are the direction pin, the direction itself, the step pin, and the number of steps per revolution. By passing that, I can create an object, and All other configurations are going to be the full configurations that we set it when we created the library. And now I'm able to send the commands for controlling the stepper motor using the driver. Okay. Here I'm waiting for 2 seconds. Here I'm turning the axis. It's 108 degrees. It's not 90 degrees. I was using 90 degrees before recording this video, but I changed the code before starting recording. Okay, turning the axis for 180 degrees, waiting for 2 seconds, giving another turn. It's not to the other side anymore. You can do that. As I said, the documentation is available on the repository on GitHub, and it's very simple to use. But here I'm giving another turn of 180 degrees, waiting for 2 seconds, and now I'm giving a full turn on the axis of the stepper motor 360 degrees and finishing the execution of the program. You're going to see it right now. The execution of the code, the stepper motor is 180 degrees, 180 degrees, and then 360 degrees. We recorded this video before starting recording the video that I'm recording right now off my screen. The code is already on my Vocore, and the scheme for wire connection on the Vocore and on the driver is the same as you can use for any other microcontroller in Arduino or Raspberry Pi or any other one. It's very simple to use, as you can see, and I think that's it. I hope you enjoy, and if you have any doubts, have any problem, you can comment on the section below. And if you have any suggestion or any new implementation for new driver or better implementation, maybe I missed something, you can send us a pull request for the repository that's on the description of this video. And good luck with your projects. Bye bye.